21 billion kilometers from the Earth, a small metal device the size of a passenger car flies. Without people on board, without fuel, without the ability to stop. It has been flying for almost 50 years and is still transmitting data. But in 2026, NASA made decisions that were previously unthinkable. One by one, they permanently disable the scientific instruments of Voyager 2. Not because they want to, because otherwise the device will simply die prematurely. This is the story of how the farthest mission in the history of mankind ends. To understand the scale of what is happening, you first need to understand how far he has flown away. 21 billion kilometers is a number that the brain refuses to perceive directly. Here's how it works in practice. A signal from Earth travels to Voyager 2 for almost 20 hours. This is not a delay due to poor internet. This is physics. The speed of light is 300,000 kilometers per second, and still it takes almost a day for a radio wave to reach the device. And then the same amount on the way back. When engineers at the Jet Propulsion Laboratory send a command and receive confirmation, almost 2 days pass. Voyager is so far away that it is physically impossible to control it in real time. And this device, this small man-made miracle, loses power. For what's every year? Slowly, inevitably, with the precision of physics that cannot be fooled in any way. And in 2026, these watts are already so small that every device turned on is a matter of life and death for the entire mission. But let's start from the beginning. August 1977. Florida, Cape Canaveral. NASA engineers know something very important. Once every 176 years, the giant planets of the solar system line up in such an arc that a single spacecraft can fly around all 4 in a row. Jupiter, Saturn, Uranus, Neptune, in a chain, using the gravity of each planet as a slingshot to rush to the next. This is called the gravitational maneuver, and such a window opened right then, in 77. The next time is in the 26th year of the 22nd century. Most of us will be gone by then. It was impossible to miss this. The program was called Voyager, and on August 20th, 1977, the first spacecraft left. The one that paradoxically received the number 2. Why? Because it flew along a longer trajectory and had to get to Jupiter later than its brother. But it was this long trajectory that gave him access to all 4 planets. The device weighed 825 kilograms and carried 10 scientific instruments on board: cameras, magnetometers, spectrometers, particle and plasma detectors. Its onboard computers are roughly equal in computing power to a modern calculator. But the main thing in it was not iron, but the idea. For the first time in history, humanity got a chance to see distant planets up close. Everything went better than anyone could have hoped. In 1979, Voyager 2 flew past Jupiter and discovered active volcanoes on its moon Io. For the first time in history, science has recorded active volcanism outside the Earth. No one expected this. Then there was Saturn in 1981, rings, satellites, details that were simply impossible to see from Earth. And then, something that no one had ever done before Voyager 2. In 1986, the spacecraft passed by Uranus. Before that, Uranus was just a pale dot through a telescope for us. Voyager 2 discovered 10 new moons, 2 new ring structures, and found that the planet's magnetic axis is tilted by almost 60 degrees relative to the axis of rotation. This is a physical mystery that scientists are still debating. Then, in the 89th year, Neptune. It is the farthest large planet in the solar system. Before Voyager, it was a mathematical abstraction for us. We knew it was there because we calculated its existence from the perturbations of Uranus' orbit, but we had never seen it up close. Voyager 2 turned Neptune into a living world, a giant storm called the Great Dark Spot, 6 new satellites, thin, almost ghostly rings. And Triton is Neptune's largest reverse-rotating moon, with a retrograde orbit that suggests it was once captured from the Kuiper Belt. After flying past Neptune, Triton went below the horizon. Voyager passed. Nothing else. The mission was originally designed for 4 years. 4 years and 4 planets. But the device worked. The solar system beyond Neptune did not end. Ahead was the termination shock wave, the heliosphere, and somewhere there, at an unknown distance, the boundary beyond which the sun ceased to be the master. NASA decided to continue the mission and gave it a new name, the Voyager interstellar mission. Some of the devices were turned off to save energy, leaving only those that are needed to study the far reaches of the heliosphere. Now we need to talk about the main thing. About what Voyager's life depends on. There are 3 radioisotope thermoelectric generators on board. Inside each are spheres of plutonium oxy-238. Plutonium decays, releases heat. Heat is converted into electricity through thermocouples. No moving parts, no complicated machinery. Just the physics of decay that works on its own, without any maintenance, in any cold, in any darkness, infinitely far from Earth. At startup, 3 generators gave 470 watts. It's about like a small vacuum cleaner. But in space, where there is no other source of energy, this is a lot. The half-life of plutonium is 238 years, that is, the power decreases slowly, about 4 watts per year. In 77, it seemed insignificant. But 50 years of 4 watts is 200 watts. Out of 470. And these are only direct losses for decay. Another part of the power is used to maintain heat inside the device, otherwise the electronics will simply freeze at a temperature of -270 degrees outside. Another part is for the transmitter, for onboard computers, for basic navigation. By 2026, there are only a few watts left for scientific instruments. Less than your phone's charger consumes. Engineers have been doing everything they can for years to stretch these watts. The heaters of individual parts of the apparatus were turned off. The voltage control system was reprogrammed. In 2023, they took a serious risk. They turned off the backup safety circuit, which stored a small reserve of power in case of power surges. This stock began to be used directly. Without a protective buffer, any sudden jump can kill the appliance. But there was no choice. Either risk or immediate shutdown. This solution bought a few more years of work. But in the autumn of 2024, mathematics finally took its toll. NASA made the first decision to turn off the scientific instrument. Forever. It was a plasma detector, the Plasma Science Instrument. One of the most valuable instruments on board. It was he who, in 2018, recorded the moment when Voyager 2 crossed the heliopause, the boundary beyond which the solar wind finally gives way to interstellar plasma. It was a historic moment of direct measurement. Voyager 1 had crossed the same boundary earlier, in 2012, but his plasma detector had failed since 1980. We did not have any direct data on plasma at the transition point. Voyager 2 gave us this data. For the first time in history, we have measured the temperature and density of interstellar plasma directly at the point where one world yields to another. After the autumn of the 24th year, this device fell silent forever. On March 24, 2025, the second device was turned off. Low-energy charged particle instrument. He measured the fluxes of ions, electrons, and cosmic rays, both those that fly from the depths of the galaxy and those that give out our sun. Inside the device was a small stepper motor that rotated the detector platform 360 degrees to cover the entire space around it. During development, this engine was tested at 500,000 steps, exactly as much as it takes to fly past Saturn. When he was finally turned off, he had taken more than 8.5 million steps. 17 times more than the calculated resource. A small engine that just refused to give up. In 2026, the next in line is the cosmic ray detector, the cosmic ray subsystem. This instrument studied high-energy particles that come from outside our galaxy, dispersed by supernova explosions somewhere in other star systems, thousands of light-years away. It was he who helped confirm that Voyager 1 entered interstellar space. When the flow of these particles changed dramatically, it became clear that the spacecraft had crossed the boundary. After it is turned off, only 2 working instruments will remain on board. A magnetometer that monitors the magnetic field, and a plasma wave detector that hears electromagnetic oscillations in the interstellar medium. With 2 devices, the device will be able to work until the early 30s. Then you will have to choose again. And at some point, there will be only one device left. Then not a single one. Then the transmitter will also fall silent. But what exactly does science lose when every device goes out? These are not just technical statistics. Behind each disconnection, a window closes, behind which no one else will be. Voyager 2 is moving in a southerly direction relative to the plane of the solar system, towards the constellation Peacock. Voyager 1 went north, towards the constellation Ophiuchus. They explore interstellar space at fundamentally different points. And it turned out that these points are physically different from each other. The heliosphere, the bubble of solar wind and magnetic fields that the sun holds around it, is not a regular ball. It is asymmetrical. Voyager 2 proved it. When it crossed the termination shock wave, the inner boundary of the heliosphere, where the solar wind breaks sharply, it happened at a distance of 84 astronomical units from the Sun. Voyager 1 passed the same boundary at 94 ranges. A difference of 10 units is 1.5 billion kilometers. The southern part of the heliosphere is literally depressed by the interstellar magnetic field, which presses on it from the outside. Before the Voyager 2 measurements, this was a theory. After that, there is a measured fact. We live inside an asymmetrical bubble that experiences different pressures from different sides. And Voyager 2 is the only human-made object that is located in its southern part and can look from there. When his instruments go out, this observation point disappears forever. Because humanity has no other device flying in the same direction. And it won't be for a very long time. Separately, it is worth talking about the incident of 2023. In the summer of that year, due to a software error, the Voyager 2 antenna deviated from the direction of Earth by only 2 degrees. 2 degrees is nothing in ordinary life. But at a distance of 20 billion kilometers, this meant complete silence. The device stopped hearing us and stopped responding. The NASA team lost contact. For several weeks, they have been trying to catch at least the carrier frequency of the signal. On August 1st, a weak signal was finally detected. And on August 4th, a special command was sent from the DSS Antenna 43 in Canberra, the only one in the world that can communicate with Voyager 2, more powerful than usual. Within the team, this signal was called shouting into the dark. And the darkness answered. The device received the command, reoriented the antenna. They waited for confirmation for almost 2 days. When it came, Voyager was looking at us again. This episode showed how fragile the bond had become. 2 degrees, and that's it. That is why every team that is sent today is repeatedly checked. It takes almost 2 days to correct the error just to transmit the signal. There is no more room for error. According to calculations, Voyager 2 will be able to maintain at least one working scientific instrument until the early 30s. Around 1934 or 1935, the power will drop to a level where it will be impossible to power anything, neither the instruments nor ultimately the transmitter. Then the signal will stop coming. Not because something will break. Simply because it will run out of plutonium. Although Voyager may die earlier, in a different way. Any component, the heater, the voltage regulator, the onboard computer, can fail on its own. At -270 degrees, any system that has lost heating freezes quickly. A software glitch could happen. In 1924, that's exactly what happened to Voyager 1, when a memory error caused the spacecraft to send meaningless data for months. Then we managed to fix it. But next time it may not work. When the final signal arrives or when there is simply no more signal, the device will continue to fly. Physics will not stop because electronics are dead. Voyager 2 will travel at about 55,000 kilometers per hour until it encounters something in its path. In interstellar space, this is almost literally eternal. In a few hundred years, it will enter the Oort cloud, a huge shell of icy bodies at the very edge of the solar system. It would take about 30,000 years to pass through the cloud. And in another 10,000 years, about 40,000 years after launch, Voyager 2 will pass next to the star Ross 248, a red dwarf in the constellation Andromeda. At a distance of about 1 7/10 of a light year. This will be the nearest star on his entire path. He will pass by her in complete silence. Dead, but still flying. With the gold record on board. The record should be mentioned separately. Both Voyagers carry a gold-plated copper disc. It contains the sounds and images of the Earth, music of different cultures, sounds of nature, greetings in 55 languages, photographs of people, animals, cities, oceans. Carl Sagan, who supervised the creation of this disc, called it a message in a bottle thrown into the ocean of space. The probability that someone will find it is vanishingly small. But it exists. While the device is flying, the plate flies with it. Here it is important to clarify one point that is often confused. When they say that Voyager left the solar system, this is not entirely accurate. It went beyond the heliosphere, beyond the solar wind and the sun's magnetic shield. It's called interstellar space, and it's a truly remarkable achievement. But the solar system, in an astronomical sense, extends to the edge of the Oort cloud, and Voyager is still hundreds of years away. Technically, it's still inside the solar system, just in the part of it where the sun's gravity is there, but the solar wind is no longer reached. Voyager 1 is moving faster, about 61,000 kilometers per hour against 55 for Voyager 2. It used Saturn's gravity more aggressively, got a greater acceleration, but left along a trajectory that did not allow it to fly to Uranus and Neptune. He went north. Voyager 2 to the south. At the beginning of the 26th year, Voyager 1 was about 163 astronomical units from the Sun versus 142 for Voyager 2. The signal to the first one has been flying for more than 23 hours. They have diverged so far that they explore fundamentally different parts of the interstellar medium, like two eyes that give volume where one sees only a plane. And that's why the loss of every Voyager 2 instrument closes questions that there is no one else to ask. Voyager 1 also dies. In February of 1925, his cosmic ray detector was turned off. The same mathematics, the same 4 watts a year, the same 30s as a possible ending. 2 devices, 2 extinctions, at 2 different ends of the darkness. The people who work with Voyager have dedicated decades to it. Ed Stone, the mission's chief scientific officer, had been with the mission for more than 50 years. He personally announced the crossing of the heliopause, looked at the data from devices that had been reading readings for years where no other human object had reached. For him and his colleagues, every shutdown of the device is not a technical act. It's saying goodbye to a part of your life. Susan Dodd, Voyager's project manager, put it bluntly, if you don't turn off the device now, the device will die in a few months. The choice is not between life and death. The choice between an imminent death and a postponed death. Each device that is turned off is a sacrifice so that others continue to work a little longer. In the history of science, there have been many instruments that have worked longer than planned. Mars rovers that traveled for years instead of 90 days. Telescopes that have continued to operate beyond all warranty periods. But Voyager is different. It has been flying for almost 50 years. He visited 4 planets. He was the first to cross the border, where no human object had reached him. For the first time, he directly measured the temperature and density of interstellar plasma. He proved that the heliosphere is asymmetrical. He told us about the 4 worlds to which there was no other way. And now his devices are going out one by one. Like lights in a house whose owners leave and turn off the light behind them. One night light is left. Then they close the door. The right word here is not tragedy. Tragedy is when something good ends ahead of time. Voyager 2 lived 10 times longer than allotted. This is a triumph. Slow, quiet, occurring in complete silence at a distance from which the light comes for almost a day. But a triumph. For what's per year? -4, and another 4, and another. Like drops that count down the years. Until the moment comes when the signal from the edge of the known world stops coming. Then there will be silence. But the record will continue to fly. And somewhere in the abyss, 21 billion kilometers away, a dumb metal apparatus launched by people who are no longer alive will carry voices, music, and photographs of the world that calls itself Earth.